Looking at 7b.4, I can recognize the relationship between complementary angles and finding the sine and cosine of the complementary angles. So we're looking still at sine and cosine, but now we're talking about these things called complementary angles. So the first thing we're going to look at is what is the definition of complementary angles. So, complementary angles are two angles that add up to 90 degrees. For example, 30 degrees and 60 degrees. If I had two angles, one that was 30 degrees, one that was 60 degrees, those would be complementary angles because 30 plus 60 is 90. Okay. And then one key fact about complementary angles is, oops, I don't know if this shoot the thinner line. The acute angles in a right triangle are always complementary angles. Okay, so again, the acute angles in a right triangle are always complementary angles. So for example, over here, right, my acute angle is here, and these two angles are complementary angles. Okay? So, now that we know that the angles of a right triangle are complementary, we're going to try and figure out what that means. Okay? So, we're still doing trig, so we're still going to use SOHCAHTOA. Right? So looking at our first one, I want to find the sine of A and the sine of I want to find the sine, cosine, and tangent of A, the sine, cosine, and tangent of C. Okay. So I'm going to start with the sine, cosine, and tangent of A. So again, across from our right angle is our hypotenuse. And then I'm looking for angle A. Across from angle A is our adjacent side. And between the two is, across from angle A is our opposite side, and between the two is our adjacent side. Okay. So looking at SOHCAHTOA, the sine of A is opposite over hypotenuse. In this case, it's 4 over 5. The cosine of A is adjacent over hypotenuse. Again, adjacent is 3 over 5. Right, hypotenuse is 5. Tangent of A is opposite over adjacent. Which is 4 over 3. And that's it. Easy enough. Now, I want to find the sine of C. So, I have to ignore these and relabel my sides, because I'm now looking at this angle C. The one nice thing is my right angle hasn't moved. My hypotenuse is still the same. But now, going across from angle C, this is now my opposite side. Between these two is my adjacent side. So, if you move to a different angle, your opposite and your adjacent side switch. This is very important because this is probably one of the biggest things that we mess up in this whole unit. Okay, so if you switch angles, you have to switch your sides as well. So now, sine of C is opposite over hypotenuse still, right? But now my opposite side is 3. Cosine of C is still adjacent over hypotenuse, but now my adjacent is 4 over 5. And tangent is opposite over adjacent, which is going to be 3 over 4. All right. So that's it for that. Let's look at our next problem. Again, I'm finding the sine of A, cosine of A, and tangent of A. So I have my right angle. Across from that is my hypotenuse. I'm looking for A first. Sorry. Something weird happened there. So across from my hypotenuse, or across from my right angle is my hypotenuse. Across from my angle is my opposite side. Between the two is my adjacent side. So sine of A equals opposite over hypotenuse, which is 8 over 17. Cosine of A is adjacent over hypotenuse, which equals, I don't know, over 17. And tangent equals opposite over adjacent, which equals 8 over, I don't know. Right, so let's use our Pythagorean theorem to figure out what that I don't know is. Right, so this is A, B, and C. So I'm going to use my Pythagorean theorem. A squared plus B squared equals C squared. In this case, I don't know A, right? Plus 8 squared equals 17 squared. So again, don't know A, 8 squared is 64, 17 squared is 289? I'm going to double check that with my calculator. Oh, sorry, 17 squared is 289. Good. Then, I'm adding 64, so I'm going to subtract 64. We get A squared equals 225. Take the square root. The square root of 225 is 15. So that side is 15. So, in all my blanks, I'm going to put 15. So now I know that the cosine of A is 15 over 17, and the tangent of A is 8 over 15. Now I need to find the sine, cosine, and tangent of B. Again, I have to start all the way back at the beginning, relabeling my side. Right angle across from it is my hypotenuse. I'm now looking at angle B. Opposite of angle B is my opposite side. Between the two is my adjacent side. So sine of B is opposite over hypotenuse. My opposite side is now 15 over 17. Right? I don't have to resolve my Pythagorean theorem. It's not going to change. Right? Just 15 is now your opposite. Cosine of B, cosine is adjacent over hypotenuse. 8 over 17. And tangent of B, opposite over adjacent. Right, coming from here. So that's 15 over 8. Alright, the next thing we're going to look at, if we look at the relationship between these. If I look at the relationship between my trig ratios and my complementary angles, you'll see we have connections here, right? These two, sine of A and cosine of C, we got the same answer. Sine of C and cosine of A, we got the same answer. Sine of A and cosine of B, we got the same answer. Sine of B and cosine of A, we got the same answer. Okay. So, what is this relationship that we found? We call it the complementary angle theorem, and what it states is the sine ratio of an angle is equal to the cosine ratio of the complementary angle. Okay, and again, this really happens because when I switch angles, I switch which was opposite and hypotenuse, or opposite and adjacent. Right? So when I switch angles, I'm switching my trig ratio too. Okay? So just like here, the sine of an angle is equal to the cosine of its complementary angle. A and C are complementary. The sine of C is equal to the cosine of its complementary angle. Same thing here, right? The sine of one is equal to the cosine of the other. Then we have the tangent of the complementary angle. These are related in a way too. So the tangent ratio of an angle is equal to what we call the reciprocal and reciprocal just means I flipped my fraction. So it's the tangent ratio of an angle is equal to the reciprocal of the tangent ratio of the complementary angle. That's a lot. So again, all I'm saying is this tangent ratio here is equal to, when I look at the complementary angle, my tangent ratio is flipped, right? It was 4 over 3. I just flip it, 3 over 4. Same thing here. When I look at my complementary angle, 8 over 15 flips 15 over 8, okay? And that's going to happen for every single time. That's a rule. All right, we are done here. There's one thing I want to mention in your activity packet. If you look at your activity packet, 7B.4, this activity, in this first example 1, all of these sine B, blah, 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 this is impossible. B is my right angle. These should all be C. Okay? So go ahead and make that change so that we don't get confused on our activity. All right, otherwise go ahead and get started, and I will see you guys next time.